Alkylation and acetylation. Friedel-Crafts reaction. The reaction involves the replacement of a hydrogen atom in the benzene ring by an alkyl or an acyl group in the presence of anhydrous aluminum chloride as catalyst. The replacement of hydrogen by an alkyl group is termed as Friedel-Crafts alkylation, whereas the replacement of H by an acyl group means RCO, alkyl group means CH3, C2H5, etc. An acyl group is referred as Friedel-Crafts acylation. Write the equation. First one, Friedel-Crafts alkylation. Write the heading Friedel-Crafts alkylation and then write the two equations. Equation number 1. When benzene is treated with methyl chloride in presence of anhydrous aluminum chloride, toluene and hydrogen chloride are formed. You must know the formula of toluene and methyl chloride and benzene. Above the arrow, write anhydrous aluminum chloride. Write the equation. Equation number 2. When benzene is treated with ethyl chloride in presence of anhydrous aluminum chloride, ethyl benzene and hydrogen chloride are formed. You must know the formula of benzene, ethyl chloride and ethyl benzene, and hydrogen chloride is the byproduct. Right above the arrow, anhydrous aluminum chloride. Friedel-Crafts acylation. When benzene is treated with acetyl chloride in presence of anhydrous aluminum chloride, an acetyl benzene or acetophenone and hydrogen chloride are formed. You must know the formula of benzene, acetyl chloride and acetyl benzene or acetophenone. Write the equation. Next is the directive influence of. O means ortho, P means para, M means meta. Substituents in electrophilic and nucleophilic substitutions. That means, for example, if the benzene ring is already having a substituent, let X be the substituent. If a substituent already present, the incoming substituent Y, where is the position it occupies? That is called the directive influence of ortho-para substituent. The Y will occupy, and when a benzene ring, in a benzene ring, the positions 1, 2, this is called ortho position. And on this side also, if it comes, that is 1, 6. That means if this side also, if the position is like this, it is called ortho. And if the position comes 1 and 3, it is called meta. This position is called ortho and 1 and 3 is called meta. And if it is the fourth carbon atom, that means 1 and 4, this fourth one, 1, 4, if it is, the substituents are occupying, it is called para. This is the meaning of ortho, para and meta. Therefore, let us see, if the substituent which is already present on the benzene ring is not possessing any double bond or a triple bond, no double bond, no triple bond, it will go to ortho and para. If there is no double bond, it goes to ortho and para. If it possesses a double bond, then it goes to the meta position. That is the explanation. Let us see. When a mono-substituted derivative of benzene is subjected to further substitution, the position occupied by the incoming substituent group on the ring depends on the nature of the substituent already present on the ring. That means on the ring, if there is a single bonded or saturated, it occupies ortho and para. If it possesses a double bond or a triple bond, it occupies the meta position. On the basis of the directive influence of the substituent groups, it can be classified into following two categories. 1. Ortho and para directing group. The substituent groups which direct the incoming group to enter the ring on the ortho and para positions are called ortho and para directing group. Some important ortho para directing groups are NH2, NHR, NR2, OH, OR, COR, R, X, etc. All these are saturated. That means all are possessing only single bond. 2. Meta-directing group. The substituent groups which directs the incoming group to enter the ring on the meta position are called meta-directing group. Some important meta-directing groups are NO2. In that, N is connected to oxygen by a double bond, and Cn, it is a triple bond. SO3H, there is a double bond. CHO, there is a double bond. Therefore, and COH, there is a double bond. Therefore, all these are meta-directing groups. Example, phenol. When it is treated with concentrated nitric acid and concentrated sulfuric acid, that is OH is not possessing any double or triple bond. It is a single bond. OH means OH. Therefore, the entering group NO2 will occupy the ortho and para position. This is known as orthonitrophenol, that is next to the hydroxyl group. And para means 1,4. This is known as para-nitrophenol. Another example, benzoic acid when treated with concentrated nitric acid and concentrated sulfuric acid. Benzoic acid possesses a double bond. C double bond O. Therefore, the entering group will occupy only the meta position. Therefore, this compound is known as meta-nitrobenzoic acid.